Okay, what is calculus? Um, so, calculus is a language. It's not just a language, but it is, amongst other things, a language. And it's a language that allows you to describe pictures in your head, particularly pictures that relate to the way at which things change, uh, the rate at which things change, either with respect to time or with respect to other things, the way they change with respect to each other. Um, it's quite a vague description, I know, but it's actually part of the human brain, calculus. You're using concepts of calculus, whether you know them or not, whether you're aware of them or not. It is part of our physical reality to have these concepts. The actual subject itself includes teaching you a language that will allow you to formalize these thoughts, these pictures, describe situations, and from the description, be able to ask and answer questions. Okay. However, I emphasize it's not just the language, because through the process of the language and describing these concepts, you learn some truths, some basic fundamental truths. There are basic fundamental truths, mathematical truths that govern the universe, and that isn't necessarily well known. So everybody's aware that there are physical laws that govern the universe, but underneath the physical laws, there's a very strict set of mathematical laws. And the universe is the way it is because these mathematical laws are there. And that might seem crazy to you if you haven't really learned or seen mathematical laws. But hopefully that won't seem crazy to you in a couple of years' time when you're going to encounter a lot of it. If you go to, well, you can't right now, but if you in some future time to go to the science library of any university in the world, go to the physics, the chemistry, the engineering, open a book, you'll see everything in the language of maths. Not literally everything, but every single page will be using the language of math. And the more advanced you go in any of these subjects, the more mathematical you'll see the descriptions, because this is a language that describes this world, and the fact that we can develop this science and describe the world uses these mathematical truths, these mathematical laws in that process. We couldn't do it without it. All right, so that is what calculus is. And that might be a long way from what you think it is. So the word computer, for us, it's a machine. We're very familiar with it. But back in the day, the word computer was a profession. There were people who did the job. The job was called being a computer. And a computer was a guy who sat at a little desk all day and calculated stuff for people. He would do exactly the kind of algorithms that we're going to teach you. And he would do them, or she would do them, but back in the day, more he than she, without knowing what he was doing or she was doing, because they didn't have to. It was just like it was like a job, a bit like a bookkeeper. Right? It's a low level office job, and these people were trained to just perform algorithms without learning what they were doing. They didn't know the questions they were trying to answer. They didn't know what the question meant. They didn't know why the method they were following actually worked to produce an answer, and they had no idea what the answer meant. None of that stuff was important because they were just at a lower level doing this grunt work. Out of a kind of a societal inertia, that's how a lot of maths is taught still. So when I was taught maths, it was exactly this, and it wasn't very interesting for me. I was taught, if you see a certain problem, then you do step 1, then you do step 2, 3, 4, and then somewhere in step 5 would be the answer. And if I see a different kind of problem, then I do whatever, step A, B, C, and then D. And wasn't super interesting, but also wasn't super hard. And I went to university as a dual major doing math because I could do this even though I didn't particularly enjoy it. And then it stopped being about this, and rightly so, because we don't need human beings to be computers anymore. We don't need human beings to do algorithms. That is a waste of time. We can't do them as well as computers. It is not a useful skill. However, it is a way to somehow begin to learn the language. It's kind of the equivalent of piano scales. So even if you've been to one of the better schools, you've certainly done plenty of this, but they would have also started to tell you more about what the concepts mean, why the algorithms you're learning work, and that's the direction that this progression is going to take for you as you learn math at university. And it starts here. And that is a jump for many people, as it was for me. I was very surprised, and I really struggled with math at university when I first started. But then I actually started to like it, really like it, and it became my profession, obviously. And hopefully the same will happen to you. But the first thing that is an obstacle is that many of you haven't really encountered math much beyond learning algorithms. And you can be very good at that, very successful at it. You can be very comfortable with it. You can feel that that's what math is. And now you some students feel like there's some kind of unfair changing of the game taking place because you're doing less of that and you're more asked to learn and understand concepts and answer questions about concepts. And some people resist. Do not resist. Trust this. Trust the process. Your common sense tells you that there's no need to do algorithms. You know well enough every single algorithm you could possibly learn in math has been programmed in a dozen different software applications. That's not a useful thing, okay? However, knowing what the algorithm is doing, knowing something about why it's working, what the answer means and what the question means, that is very valuable. That is supremely valuable. There are not nearly enough people with those skills. So that is what you should be aware of, that we're going to gradually shift the game for you. We're going to focus more and more on what these things mean and less about how do you compute things by following a sequence of steps. And those things are interrelated because the better you understand what things mean, the more natural the steps are. You don't have to memorize things. Something I'll be emphasizing over and over again is that we're not going to memorize. Memorization is forbidden in math. We are going to understand. And if you understand, it'll be simple. It'll be elementary. It'll be common sense. And I'll give you many, many examples. Okay. Another thing that I want to emphasize is that this particular part of math is highly visualizable. The title of my YouTube channel is Calculus is Pictures, and that's kind of a simplification, but that's what I'm going to be telling you over and over again. We are going to talk about concepts. I'm going to write them down in this symbolic language, and I'm going to draw a picture. And the stuff I write in the language will correlate to the picture. There will be a direct one-to-one, backwards and forwards from the language to the picture, almost like a kind of dictionary. Yeah, kind of like a dictionary. The language is to describe these pictures, but they're pictures we can draw, but as you get better at this, it'll be pictures in your head. So you'll look at some maths and you'll have the pictures in your head, and you'll read some explanation, some argument in math, and you'll see pictures moving around in your head, and it'll be meaningful to you. It'll make sense, and it'll actually be enjoyable and actually beautiful if you get deep enough into it. So that's something I emphasize a lot. If you look at my previous lectures, you'll see the amount of time I'm drawing pictures. Practically everything I'm going to tell you about, I can directly draw a picture for, and I'll be doing that all the time. And that's what you should do too. You should not be happy with something until you can draw a picture of it. Okay? This is so deeply visualizable that's something you've got to grab onto right now. The faster you learn this, the easier math will be going forwards. You very much don't want this to be just some kind of thing where there's these symbols and you're trying to remember them, but you don't really know what they mean. And some people have fantastic memories, and some people get quite far with this, but it's essentially like memorizing a bunch of pin codes. Or a better metaphor, it's like learning a language without trying to understand the meaning. So imagine if I was your German teacher and I said to you, when you hear the sentence, "Was machen wir heute Abend?" you respond with, "Wir bleiben hier zu Hause." And I don't tell you what the question means, and I don't tell you what the answer means. I just tell you when you hear that question, you respond with that answer. And I could do this with a whole long list of questions, and I can give you a whole long list of answers. And you can go to Germany, and then you'll have a conversation, and you'll hear a sentence that you recognize, a question you recognize, and you respond with something, but you don't know what has been asked of you, and you don't know what you replied with. That is how math is taught when it's taught in a very bad way, in a way without this emphasis on the concepts. And that's perhaps okay at the very beginning. Again, the metaphor of piano scales, but it's not okay here. So the pitches are, for our purposes, going to be the meaning. Get used to turning it into pitches all the time, as I'll show you how. Focus on this. Okay, some propaganda, some proselytizing for this. I watched a YouTube video of some guy. Maybe it was a TED talk, and this guy was a mathematician, professional mathematician, actually a serious one, and he was saying that he tries to explain what math is like. It's like having a set of X-ray goggles, which is a nice metaphor, because indeed, if you do your next 3 years, 2 years of study, and you get a minor in math and you learn it well, you will have a set of X-ray goggles. You will have this extra layer of information that you see all the time in everything that you do, and that will be unimaginable to you after the fact. What I mean is that not having that would just seem like an incredible loss after you have it. Everybody agrees that learning to read and write is incredibly valuable, right? No serious person would claim you don't need to learn to read and write, right? So let's say reading and writing is 10. Basically, everybody agrees you need to know basic arithmetic just basic numerical ability to do arithmetic, to have some idea of figures, whatever, just the very simplest minimal amount. If you don't do that, then you just don't know what things cost. You're just in a mess, right? You don't know how much you're being paid. You can't function. So let's say reading and writing is 10. Numeracy is at least, say, 6. Basic. Calculus is 4. If you have calculus, it's as good as it's 4. If literacy is 10 and numeracy is 6, calculus is 4. That will be that impactful to your life. Not just this course, but calculus 2 and multivariable calculus. If you get those solidly in your brain, you will have this. You'll have these X-ray goggles all the time, and I would feel vulnerable and lost without it. There's a very famous 20th century Soviet physicist called Lev Landau. If you go to a library, you'll see these Landau-Lifshitz physics books. There's like a whole series of them. They're like one of the main textbooks of the Soviet era. Very, very good textbooks, and still being used. Landau was kind of a prodigy, and he once said that he doesn't remember a time when he didn't know calculus. It's such a basic thing in his brain. I do remember a time when I didn't know calculus, but I would not want to go back to that time. So I'm happy to teach this course. I teach courses at all levels. I teach at the highest graduate level all the way down here, and in all subjects, and in a very wide range of subjects. And I'm very happy to teach this stuff because because I believe in it, because it is so important. It is. If you do this, if you do take this seriously, this will literally change your life for the better. It won't just make your degree easier to get. It won't just give you a better GPA, a better job. It'll just change your life. It'll just change your. It'll give you a set of. It'll give you these mental tools, this framework to understand things in, and many things will be transparent to you. I hope you are coming into this with a sense of optimism. It's going to be a lot of work. It'll be a long process, but the payoff is huge. I wouldn't teach this if I didn't believe this, and you can probably tell I mean what I say. Okay. What else to say? Okay, so how you should do this course? Well, it's a 15-week course, and as I said already, many of you come from very good schools, where you've been well prepared. Every year there are many, many people who don't, and this will be a shock for them. My metaphor for it is it's like the mental equivalent of learning to run 5K in 22 minutes. And everybody can do that. But if you haven't done that or anything like that before, then you're going to have to get there gradually by doing the training week by week. Back in the day, a long time ago, I was a mediocre level competitive runner, and I would do interval sessions with the rest of the running team, with a professional coach, with some national level runners, and not that I was at the level, but some of them were. And what I noticed is that if I mean, interval sessions are incredibly brutal. If I ever missed them, then the next one would be so much worse. Right? So if you've done them yourself, you'll know what I'm talking about. There's nothing more painful than a tough interval session. But I learned that no matter how I felt, no matter what excuses I was tempted to give myself, I had to go and complete them because I just wouldn't be able to keep up with the escalation of difficulty that we were being put through. Hopefully this course will not be as painful as doing interval sessions, but it will be painful if you get behind the training. If you don't keep up with the training everybody else is doing, don't keep up with the schedule, then it's going to be hard to do. If you try and float and just not make a full effort and get further and further behind and then think you're going to catch up, then you'll make it a very stressful experience. That's the painful way to do it. And it's not completely impossible, but I've taught this course many times. I've seen students who do this every single year, and I understand you arrive in a new world, you have many distractions, you have many things in your mind, and then week 7 comes along and you've blown 2 midterms and you're quite concerned, and then you try and get serious, but then it's then only a small fraction of those who try and recover actually do, because it's just very hard. You're gonna be doing all the training you've missed in a shorter period of time by yourself, with none of your friends will be at that stage. They'll be way ahead of you. You'll have to do a lot of lonely, hard work by yourself. And some people have the discipline to do that, but it's much easier to stay with the pack. You stay with the pack, stay with everybody else, keep up with everything, use the resources we have. That's the smooth way to do this. If you trust this process, do everything we ask, that's by far the best way to do it. So keep that in mind. be one of these people who get left behind and then are just stressed and then struggling and then often, mostly actually not succeeding to catch up. Stay with the pack, stay with everybody else, do the training regularly. That's the way to study this course. Okay. I think that's everything I wanted to say. Alright, so I will meet the first third of you on Monday. I look forward to doing so. Please think about everything I've said and come ready for this, and I think we'll have a great time. All right, see you on Monday.